you, Chairman, for introduction. Good morning, ladies and gentlemen. I am Akihiro AIDA from University of Tokyo, Japan. Today, I would like to talk about my research estimation of commercial area changes with tenant-agent model. First of all, I talk about introduction. Recently in Japan, many local cities are facing many problems. For example, suburban expansion accelerated by large shopping mall. Look left picture. This is an example of large shopping mall. And for this problem, for local government, cost of infrastructure are increasing, especially in suburban area. On the other hand, in the center of local cities, small company and private shops are decreasing. Look at this right picture. This is we call this area shuttered storage. Many shops, private shops are closed. One reason of this problem is no successor for small private shops. Many private shops are owned by elder people, and most of their children won't succeed. So many private shops will have to close. About these problems, there are some previous studies. One of them is case study of commercial area. This type of study provides interesting results, but study area are very limited, so these did not cover the supported decision of many cities. Another study is focused on specific type of tenant or shops. It does not cover all type of shops. So this study cannot tell what to do next for government. Another study is about the impact on the regional economic. These studies are macroscopic, so did not suggest any about detailed change in microscopy. Most of these previous studies are quite limited in understanding change of microscope. It was not sufficiently to tell us what to do for government. So if we can understand why commercial area change in detail, it would be useful for marketing and urban planning. To understand the detailed changes, we need microscopic tenant data. Actually, we can get tenant-based data by digital telephone directory, like this. This is a time series change data of tenant made with telephone directory of each year. This is point-based microscopic data showing continuation, close, and emergence of each shops, and covered all over Japan. From this data, we could get actual result and of tenant behavior. This data is for verification of simulation model. In this study, we use especially literal tenant. That means shop. But this data is just a description of detailed changes. So to support the decision of government, we need to understand why tenants are changed. How tenants decide the next action, which counter is measurable to understand commercial area changes, regional characteristics. So in this study, we developed agent-based simulation and tried to estimate and understand how tenants are changing. Next, I talk about purpose of this study. First purpose is modeling tenant behavior. To estimate detailed changes in the model, tenant being actor and decide action by some environment factors. In this approach, we try to understand which factors determine and what influence tenant action. Second purpose is verification of the model. We verified by comparing with actual result and simulated result. Actual result is ordinary. So, final goal is estimation of future situation in commercial area. To estimate future, we need to improve the model to simulate in various areas and various periods. This is the flow of the model. From first tenant data, we try to simulate future tenant state with multi-agent simulation model. Look like the curve of the flow. And to verify the model, we use time series tenant change data. For example, we use tenant data, state data as of 2000 as past tenant data and data as of 2005 as future tenant data. We compare to verify the model simulation data and actual data. Lower short. And now this time series data is I've already introduced previous slide. This time series data changes is change of tenant data, and this is point based. Let me skip this slide. Next, I talk about agent simulation. Our structure of agent based simulation model. In this model, each tenant decides what to do next by referring its attribute and environment variable. Like lower picture. We estimate probability of selection with logit model by like equation. V means return of each selection, and P means probability of each selection. When one selection's V is larger than other selection, the selection's probability becomes larger too. We are decided by each factor of tenant behavior. That is environmental variable and tenant's attribute. And we simulated next action of tenant with estimated probability by estimated parameter or factor. This is the flow of tenant behavior. We have two selections for the model. Two sections are continue or close, new, open, or not. Existing tenants select continue and close at next year. And owner of the vacant tenants select open new tenant or not at next year. In this study, using tenant data as of 2000 as past data and data as of 2005 data as future. In selection, tenant referred to variable of factor. This means attribute of and environment. At the opening of tenants, we need to estimate the type of new tenant. Next about factor of tenant behavior. We chose factors of tenant behaviors: population density, type of tenants, and tenant density. These data were generated from population census of Japan and data telephone directory. And the category of tenants is shown in this table. We separated tenants as convenience products and shopping products stores. Convenience products include grocery store, supermarket, and convenience store, and so on. Shopping products are like clothing, furniture, books, glasses. We classified shopping products shop more detail, like this table. About these factors, we estimated parameters by maximum likelihood estimation with time series change data. I show example of simulated data comparing with actual result and simulated result. That step is verification of the model. I selected study area as Shinjuku Ward in Tokyo. This is the Tokyo prefecture. And Shinjuku Ward is in Tokyo prefecture. This is Shinjuku Ward. And this area is hottest area of commercial and business in Tokyo. Like that. This is a distribution of tenant and its changes of continued or close action from 2000 to 2005. Left picture is actual data and right picture is simulated data. Blue point means location of continued tenant, and the red is the closing tenant. Green line means railway, and yellow area is Shinjuku Ward. From this picture, we can see probability of continue was simulated rather than actual. It means the number of red point is simulated lower than actual data. Zoom in near the Shinjuku station area. We can see the number of closed tenant red point is lower than simulated area. Shinjuku station has the largest number of passengers of the world. And to look by type of tenant, this graph means number of survived by type of tenant. And the number in this graph means ratio of simulated data by actual. Most type of tenant are simulated larger probability of survival, more than one number. Especially vehicle shop and net shop are simulated with largest error, 1.64. The reason of them is not clear now. This is future works. And lower table shows aggregation number of tenants. This is hitting ratio by type of tenants. There are no participate difference in most of tenants. And high ratio of all tenants is hitting ratio of tenants is 55%. It's lower, I think. And conclusion of this study, we could estimate the detailed change of tenant by agent-based model and simulation. And to verify the model, we compared simulated data and actual data. About accuracy of this model, probability of closing was estimated lower than actual results. especially vehicle and pet shop could survive more than actual. The reason of them is not clear now, so we must consider next. What other type of can simulate it like actual? Heating ratio of each tenant is 55%. About attribute and factor, type of tenant has effect on the probability of survival, but tenant density has little effect on probability of survival. Reason of this may be tenant density could affect by tenant type, so we must consider more detailed factors. Which facts is that further we need further analysis on other factors and estimating of emergence tenant type. That's all. Thank you for your attention.
Thank you, Aida. Any questions? Please.
I think this is a very interesting idea. I do have a couple of questions. First of all, was your simulation model multiple steps, or did you basically just do one step from 2000 to 2005?
Now I simulated only one step, but next step I separated more steps.
I think that would give a more realistic picture, since every time a tenant decides to close or to continue, it changes the distribution of tenants, and the distribution of shop types, and so on. My other sort of comment, more than a question, is that in looking at this sort of phenomenon, I think that rent is a really critical question. The cost of space, certainly from what I can see in both Thailand, which is where I live now, and in the US, which is where I come from, that's possibly the single most important factor in whether a business would close or not. And I'm sure you can get that data also, you know, sort of average rents in different parts of a district, and could incorporate that into your simulation.
Oh, thank you.
Thank you for valuable information. Any response, or you will take it for the next study?
I didn't have the data of cost of tenant area and distance of ground station and so on. So we try to get and
It would make your model more accurate, give you better results.
Thank you.
Okay, thank you. Any others? Okay, thank you. Our last presenters is Itabashi from Japan. His title is a method for constructing urban extended